If Aston Martin turns into the pit lane before the Australian Grand Prix even starts, it will be the most shocking opening race moment in years. And this is not clickbait. Days before Melbourne, reports revealed Honda arrived with critically low spare parts after structural vibration issues damaged battery components in testing. We are talking about a brand new power unit, a two-time world champion behind the wheel, the most successful designer in modern Formula One overseeing the project, and a scenario where the car might retire on the formation lap. Not because it is slow, because it might not survive. Battery stress, engine resonance, restricted power maps, limited electrical deployment. This is not a performance issue. It is a structural risk. Start the race and gamble the season's component allocation. Or pull in early and protect a multi-year project worth hundreds of millions. We are days away from the first Grand Prix of the year. Global audience, maximum pressure, zero margin for failure. And one formation lap could decide whether Aston Martin begins a new era with ambition or controlled retreat. Stay with me, because one overlooked technical detail about Honda's power unit changes everything. Now let's go inside the part that makes this truly dangerous. Because the headline is not just low spare parts. It is how they got there. During testing in Bahrain, Honda's new power unit began producing abnormal vibrations. Not small fluctuations. Structural resonance that aligned with the chassis and battery casing. When vibration frequencies match the natural frequency of the structure, the energy does not fade. It multiplies. And in this case, that multiplication caused internal battery damage serious enough to stop Alonso's car for safety reasons. Safety. That is not a word engineers use lightly. Now think about what that means. The battery in this new generation is integrated into the monocoque. It is part of the survival cell. When the structure vibrates, the battery feels it directly. So this is not about swapping a faulty unit. This is about managing how energy travels through the skeleton of the car. And here is where the situation escalates. Testing mileage was dramatically lower than rivals. Aston Martin completed just over 2,000 kilometers across pre-season. On the final day in Bahrain, they ran fewer than 10 laps because they did not have safe power unit components left to risk. Let that sink in. Before race 1, component stock was already compromised. That is why some reports say Honda even considered not traveling to Australia at all. They decided to go, but not fully prepared. Instead, they rushed what insiders call a survival package. Reinforced battery mounting points, revised engine mounts, structural stiffness adjustments, and conservative engine maps to avoid dangerous rotational ranges. But even those close to the project admit this is not a full solution. These are partial countermeasures. And that is the key phrase. Partial. Which means the vibration problem is being managed, not eliminated. Now imagine what that implies for Melbourne. Albert Park has long acceleration zones, heavy braking, strong energy recovery demands. Electrical deployment is critical for competitiveness there. But reports indicate the system may not even be recovering energy at full lower threshold levels discussed internally. So performance will be restricted. Deployment will be cautious. Engine rev ranges may be deliberately limited. And when you combine restricted power with limited spare parts, you create a fragile opening weekend. Because in modern Formula One, component allocation is strict. Destroy a battery pack in race 1, and you begin the year already on the edge of penalties. Blow a full power unit, and your season strategy collapses immediately. So now ask yourself this. If during the formation lap vibration levels spike again, if the telemetry mirrors what they saw in Bahrain, would you risk running 300 kilometers? Or would you protect the entire development cycle? That is the calculation inside the Aston Martin garage right now. And this is only block 1. Because next, we need to talk about Adrian Newey, and why his philosophy could make a formation lap retirement not just possible, but logical. Now let's talk about Adrian Newey. Because when you place the most successful designer of the modern era into a project, expectations change instantly. Newey does not build for headlines. He builds for cycles, for foundations, for regulation shifts that last years, not weekends. And that is why this situation becomes even more delicate. If the architecture between power unit and chassis is unstable, Newey will not treat Australia as a must-win event. He will treat it as a structural audit. Remember, the vibration issue is not isolated to one component. It is an interaction problem between the engine and the chassis. That means responsibility is shared. Honda cannot fix it alone. Aston Martin cannot fix it alone. The integration must change. And integration changes take time. You are not just reinforcing a bracket. You are altering stiffness distribution, mounting geometry, energy pathways. And every change influences weight, balance, aerodynamic platform. Which brings another uncomfortable layer. Reports suggest the AMR car may already be struggling with weight targets. If you add reinforcements to control vibration, you risk adding mass. If you add mass, you compromise lap time. If you compromise lap time, performance deficit becomes visible. And here is where the strategic mind of Newey matters. He understands that burning through hardware in Race 1 could limit development options later. Power unit allocations are restricted. Battery units are restricted. If you destroy components early, you face grid penalties down the line. Or worse, you divert engineering resources into emergency reliability work instead of performance gains. So imagine the formation lap. Newey is not watching just speed. He is watching trends. Are vibration levels stable across different throttle applications? Is resonance increasing under load? Is the battery casing absorbing more stress than simulation predicted? If the answer to those questions becomes uncomfortable, the logical move is not bravery. It is withdrawal. And that is why a formation lap retirement, shocking to fans, might actually align perfectly with Newey's long-term philosophy. Because his focus is not Australia. It is the entire regulation era ahead. Now add Fernando Alonso into this equation. Alonso does not tolerate fragility. But he understands strategy. If he feels abnormal oscillation through the steering column, if the car behaves unpredictably under acceleration, he will communicate it immediately. And if the word unsafe enters that radio exchange, the decision becomes almost automatic. Box. Retire. Protect the platform. Because here is the brutal truth. A dramatic failure on lap 1 would do more reputational damage than a controlled withdrawal on the formation lap. One looks like crisis. The other looks like discipline. And in a project built around long-term ambition, discipline may matter more than pride. But here is the twist. If the car runs cleanly, even under restricted maps, and finishes the race safely, it buys time. Time for Honda to refine the vibration killer package. Time to validate data under race conditions. Time to push toward the deeper plan B already in development for later races. Everything hinges on stability. Not outright pace. Stability. And that is why Melbourne feels less like a season opener and more like a stress test. A checkpoint where one quiet decision, made before the lights even go out, could determine the direction of an entire project. Because in Formula 1, sometimes the most important lap is not the fastest one. It is the one where you decide whether to keep going at all. Now let's go even further, because this is where the entire narrative could flip. Imagine Aston Martin does retire on the formation lap. The cameras capture it. The commentators react instantly. Social media explodes within seconds. From the outside, it looks like failure. But inside the team, it could mean something very different. It could mean the internal safety thresholds were triggered exactly as modeled. It could mean the vibration limits, defined before the weekend even began, were crossed under real-world load. And that would confirm one critical fact. The simulations were accurate. Because here is something most fans do not realize. Before a car even rolls onto the track, engineers define operational boundaries. Maximum vibration amplitude. Maximum battery casing load. Maximum thermal stress during energy deployment. If any of those cross a red line, the protocol is clear. Protect the hardware. Now think about the psychological impact. If the team chooses to retire before the race starts, they control the narrative internally. They can say the system flagged instability. They can say they followed safety protocol. They can present it as engineering discipline. But if they start the race and suffer a visible failure, smoke pouring from the rear, sudden shutdown on lap 1, that narrative disappears. Because public mechanical breakdown suggests something worse. Lack of control. And in Formula 1, perception of control is everything. Sponsors invest in precision. Manufacturers invest in competence. A dramatic failure questions both. So the formation lap becomes the final decision gate. It is the last moment to withdraw without the visual damage of a race breakdown. And that is why the scenario feels so realistic. Now let's widen the lens one more time. If Aston Martin survives Australia, even with limited power and conservative deployment, they gather invaluable race distance data. 300 kilometers under real conditions. Energy cycles. Thermal stress. Vibration patterns across fuel loads. That data feeds directly into Honda's deeper development program. Because remember, there is already a longer-term revision in the works. A potential new specification later in the season, designed not only for reliability but for performance recovery. But that evolution only happens smoothly if the current platform survives intact. Destroy too many components early, and the development timeline compresses. Pressure increases. Mistakes multiply. And once mistakes begin compounding, recovery becomes exponentially harder. This is why Melbourne feels like a crossroads. Not a championship decider. A structural decider. If the vibration countermeasures hold, even barely, Aston Martin buys time. If they fail under race conditions, the season begins with instability. And instability in Formula One spreads quickly. Confidence drops. Aggression decreases. Decision-making becomes cautious, which ironically can slow development even further. So when the grid forms in Australia, do not just watch the front row. Watch the green car. Listen to how it sounds on acceleration. Notice whether Alonso seems restrained. Pay attention to the body language on the pit wall. Because if the car peels into the pit lane before the lights go out, it will not be an emotional reaction. It will be the result of predefined thresholds being crossed. A calculated move to protect a long-term vision that extends far beyond Melbourne. And if they do continue, and the car survives, that quiet success may be more important than any point scored. Because sometimes in Formula One, the biggest victory is simply proving the foundation will not crack under pressure. And in just a few days, at the first Grand Prix of the season, we are about to find out which version of this story becomes reality.